Good morning, good day, and welcome back to another Metrel webinar. My name is Tamara, and I will moderate today's event. My colleague Pavel will introduce a brand new product in the segment of transformer testing, MI3281 Winding Resistance Analyzer. It is an easy-to-use tester for testing even the largest power transformers with a test current up to 20 amps. Janez will be the host and operator of this webinar and available at the end together with Pavel to answer all of your questions. Pavel, please, the floor is yours.
Thank you, Tamara. As Tamara mentioned, today I will introduce you to a new product, the MI3281 Winding Resistance Analyzer. This is an instrument for which the name itself tells you that is for measuring the winding resistance. This time without any limitations in the size or power of these instruments, of these transformers. We can test with scalable current from 10 milliamperes to 20 amps. It can be used for single phase or three phase transformers with tap changers or without, and especially we can control, if this is a motor-driven tap changer, we can control the tap changer, so the automatic tests can be done. And yeah, as usual, instruments from Metrel of this type, simple use, the user interface is already well known, so no big training needed. And for advanced user, also auto sequences are available. Once again, the key features: winding resistance is the main feature of this instrument. We can perform automatic tests with the control of the tap changer. We can demagnetize the transformer after the measurements. We can use auto sequences. We have visual tests supported, and so on. With the classic 3.3-inch color LCD touch screen display, which is the typical standard user interface for Metrel instruments. Also supported the instrument with all the needed accessories, also with the PC software supported, and the communication could be also with the Bluetooth. For sure, we are complying with all the needed standards for the safety and recommended functional standards. So go to the next. As I mentioned, there are actually no limits for these instruments in the size of the transformers. So we can test from the small distribution transformers up to big transformers in the transmission network, power network. The instrument is equipped with very simple accessories. Actually comes out with 3 different sets of the cables, 5, 10 or 50 meter long cables. The rest of the accessories almost the same. What we are using, cables for always these 2-wire cables, which makes possible to perform the 4-wire measurement technology. The clamps are always these Kelvin clamps for big transformers with big terminals. The jaw opening is here up to 65 millimeters. Can be used optionally, can be used also the other clamps, which are also very known from DTA, for example. And these long cables are on the reel, which is also actually only for transportation of these cables, but makes it very simple use of these cables. And yeah, sometimes if we are connecting to very high transformers terminals, we need some additional fastening of the cables because of their own weight. So one typical set of this instrument, clamps 8 times, cables on the reel, and additional tap changer control cable, power supply USB, and that's it. Back for accessories altogether. For sure, this instrument can be controlled locally on the instrument itself, but usually, as with Metrel, we have always supported PC software, which enables you to perform the prepare the test in advance, upload that to the instrument. Results then which are saved on the instrument can be then downloaded back to the PC software, where you can analyze the results, create test reports like this, analyze the results in numerical, graphical form, and for sure you can also prepare here the auto sequences if you are an advanced user. How does it look, the measurement itself? As I said, we can perform resistance measurement of single phase transformers. It's not something special. Or you can perform the measurement on the three phase transformers. What does that mean? That means that we connect all 6 or 8 cables at the same time to all the terminals of the transformer. So we don't need to, between one and two next measurement, to switch the cables, the clamps from one terminal to other terminal. Once connecting, performing all the needed measurements, and then disconnecting the cables. Each cables are colored, terminals are colored, connectors are colored, so you cannot make a wrong connection. And if you're not sure if you're doing correct, you have always the help screens like this, which you get on the screen, and you can then without doubt how to connect the cables. On all sizes of transformers, from single phase to three phase transformers, different configurations are possible to test. Here the screen of results of one phase transformer. You see values immediately out in different range. Usually you can set up the parameters. Here on the right side we have output of measurement of the three-phase transformer, where you have much more data which can output of the measurement. So also I will explain later results in two forms. You can see the current and all other values for low voltage side and for high voltage side. If you are testing big transformers which have motorized tap changer, you can control them also with the help of the instrument itself. So you connect additional cable, control cable from the instrument to the tap changer controller, and you can perform the tests, winding resistance of all positions of the tap changer automatically. That means you don't need to switch anything manually, but just set up the measurement correctly. So you see here, for example, we have tested here a transformer with the 21 tap positions. We have set up the configuration, defined where to measure, the test current, and then the measurement process started. It takes time. The instrument performs check, performs measurement of all windings on all tap positions, and after the measurement is finished, you get the results in number forms, or in this case, also in graphical forms. So you see here, for example, this was measured on the tap changer with 21 positions. The transformer was new. This was tested in the factory. That's why also all three lines are the same. So that you don't see, actually, here are three lines, not only one, but are, as everybody would like to see, the same. After the tests on a transformer are finished, you can also perform the demagnetization, which is treated as a measurement, even if this is not a measurement. It's only a process which you start, wait until it's finished, and that's it. So what is, let's say, something new or special in this instrument compared to his, let's say, younger brother, the digital transformer analyzer? With winding resistance analyzer, we get the results in two different forms. You must know that basically the winding resistance meter measures always the resistance between two the transformer terminals. So we have, you know that we have different configuration, or delta or epsilon configuration, star configuration. And if you measure the resistance between, let's say, H1 and H2 terminal, the measured resistance is always a combination of three winding resistances, H, B, and C. Here are the formulas, how this relation is between measured, what is the between terminals, and actual values of the windings. So this relation. Maybe simpler one is the star connection, the epsilon connection, where you again measure always the winding resistance between x1 and x2. So you always get between x1, you get the resistance of the winding A and winding B, and so on. So the results are then presented on the two different screens, screen 1 from 3 and screen 3 from 3. So you see, get here, on first screen you get the winding resistance between terminals, which is measured, and final, the calculated resistances of each individual winding here. So that's the difference between this one and this one. So sometimes this value will be the same. Depends, for example, in this case, depends, is it 0, is the neutral accessible or not? If it's not accessible, then the values will be different. If it's accessible, then the instrument always measures the terminal between terminal x0 and x1. And this is equal, the same as the winding resistance. Two methods of representing the results. The next functionality which is also implemented in this instrument is the temperature conversion. Here the fact is that the transformer is measured, the winding resistance is dependent on the temperature of the transformer itself. So we have to measure somehow the temperature of the core of the transformer. Usually you measure this with thermometers which are already built into the transformers. Sometimes you can take the temperature of the transformer with the help of infrared camera, so that you measure the temperature of the body of the transformer. So you don't measure with the own sensors which are connected sometimes to the instrument, because it's actually, you will never get the right temperature in that way. So the best is always to read the temperature of the core on some displays or thermometers which are already built on the in the transformer itself, and enter that temperature into the input screen of the measurement. Let's say, for example, the thermometer on the display, I can read that the core temperature is 31 degrees Celsius, and I want that the results are recalculated to the reference temperature, which is usually somewhere 87, 85, 75 degrees Celsius. It's up to you, it's not standardized. And over this temperature of this formula, then the final value which you see on the screen is calculated. So the instrument does that calculation, so you only have to define for such measurement which material have you used, which is the actual temperature, and which is the reference temperature. You can also enter some special, if you have some special materials, you need to know the material temperature data about that instrument, about that winding. And finally, with this instrument, if you are using PC software, Metrel Meson software, if you're using this and you have additional Pro license, you also can generate the professional report, which looks like this, something like this. So first page with all the technical data about the transformer, who is the owner, who is testing, and so on. Additional comments can be added, configuration basic is added, and so on. The next page includes the data of the winding resistance measurements, all numerical and graphical form. of the primer side, on the secondary side, usually only not numerical, and includes this report and includes also a report for the transformation ratio measurement, which cannot be done with this instrument, but with the digital transformer analyzer. So with this last release of the PC software, also professional reports for the DTA, for the digital transformer analyzer, are supported. Short about visual inspections. As classic, you can add also this one as a test. Define, these are some already predefined. You can include this test into the auto sequences, so you can have the measurement of one transformer on the full control from the beginning to the end, and everything is then also can be stored and can be inspected later on. So this is from my side for today. I will leave the word back to Tamara, and if you have some questions, please, we will try to answer you.
And as I can see in the chat, we have quite a few questions, and I will let Pavel and Yanis start answering them. Please.
Yeah, thank you, Tamara. Thank you, Pavel, for the presentation. We received several questions. And the first one is connected with the DRM dynamic resistance measurement. Pavel, can you comment?
Yeah, for the moment that in this version, this function is not supported. We will see if we can add it in some future versions, upgrades, or maybe in other type of the instrument. Next.
Thank you. The next one is connected with always open questions. So when we will support our communication also with other operating systems. First priority, of course, is Windows. And then we have Android support, and iOS is on the way. We are thinking about it, and we will try to support this in the future. At the moment, we have no date when we can support this part. And the third question which appears here is how is the wiring diagram of the OLTC control cable? Pavel, this would be a question for you.
Yeah, okay. First, I will show the instrument. Here you see is the terminal where you connect the tap changer control cable. And if you look then to the diagram, here you see, just a moment, the right one here. In this picture, you see the interconnection field on the instrument. Here you connect the cable, and the others, this one, RS232 side, and the other side are just normal bananas. Here you connect to the control box or whatever is that there usually on the transformer, where you have possibility to control the tap changer up or down. In the instrument itself is actually only a relay which opens or closes between red and black or between blue and black. This is a typical input for controlling the tap changer. Sometimes you have to add a little bit change. It's not the bananas. Maybe some adapter is needed, but no big change in the adapting. We are not connecting to some buses of the modern transformers which are completely remote control over the different control buses. This is not our case. So just simple connection where we control a relay with closing and close and disconnect the contacts of this relay. So that way we control the up and down of the tap changer. This is.
Yeah, thank you, Pavel. Another question is for the request for a heating test in micrometers.
Heating.
It is like measuring temperature or
heat test. No, that test is also not supported with this instrument.
And another one is regarding the 50 amp for the future. So the 50 amp tester, yes. The 50 amp version?
No, 50 amp version, we are not thinking about 50 amp version because till now we didn't see an advantage with such high currents. So the tests which we have performed on the big transformers have shown that with 20 amps we get same results in the same quality as with the bigger ones, with bigger current.
Usually 50 amp in combination with this tester is also connected to some other tests, let's say for continuity or micrometers for different purposes. And Metrel is covering this range with other products. So you have plenty other solutions where we test with higher currents for, let's say, a micrometer with 100 amps can achieve a resolution of 1 nano-ohm. Another solution is for the substation measurement with up to 300 amps. Micrometer within the 3144 model. And similar solutions are well accepted for this purpose, and we do not really see the advantage of winding resistance analyzer for so high current. On the other side, we have another question which would like to, so the customers would like to see the handheld version of the same instrument, which is the opposite way. So this is also a version which we already support with the 1 amp version. Is a DTA analyzer, which is a good combination with the winding resistance tester, three-phase plus transformer ratio. So it's there are two instruments in one, and it was a big success from us when we designed this product. And this is a bit lighter version. It's not so handy as handheld testers. And for that purpose, for three-phase solutions, we do not really see the advantage also for handheld, because the heaviest part of this tester are cables and accessory, which is more difficult to handle with than with instrument itself.
We must,
Pavel, yes.
Yeah. Yes, we must be aware that if we are speaking about winding resistance measurement with 20 amps, with output of 30 volts, which is needed for measuring on big transformers and so on. And you also have to know that we are actually measuring inductive loads. That means the measurements take time. So combining all the power and time, it's not something what is typical for a handheld instrument. You need a big volume of battery, which is typically for handheld instruments, and it's simply technically not possible to realize something like that. You would need a quite big accumulator to make a measurement with this instrument on big transformer with the battery. That's why you have only the public power supply, external power supply, not battery driven.
Okay, thank you, Pavel. Another question is connected with the form of the measurement between voltage 1 and voltage 2 input or resistances, and how the Metrel is giving the results for a free angle method or in between phase, or measuring in free angle as a total. Can you maybe, Paul, comment again the way of connecting?
Yes, I will again go back to the presentation. This part. So that's what was sometimes confused in digital transformer analyzer, because in the digital transformer analyzer we have only this form of the output. We show only the winding resistance values, which, as I mentioned before, are different compared to the resistance measured between two terminals. Depends on the configuration of how the configuration is done. Is it delta? Is it epsilon, z, and so on? So simple this case, for example, once again, if you look here, usually the instrument you can connect to X1 and X2, and you measure the resistance between these 2 points. So means you measure the resistance of 2 windings, winding A and winding B. So in winding resistance analyzer, you get in first screen this value, which is value between X terminals 1 and 2, and represents 2 windings. In DTA, you got, after all the measurements have been performed, you get the results, which are calculated values of all these results here. So in winding resistance, you get 2 screens. One screen is winding resistance between terminals. This is typical output also of other instruments from competitors. And the second screen gives you the information about winding resistance of individual winding A, winding B, winding C. This result gives you much better overview if everything is okay. No big difference between one form and the other form. But if there is something wrong on the windings, if there are some contacts in between individual windings, there is much more visible where the problem is in this form. Because if for example, the winding B has some shortcuts inside of the winding, you will see here that this is in this one, but if you look these results, you will always see some problems on all numbers will be different, but they don't indicate you exactly where the problem is. In this form, you get the information where the problem is. So better form, but directly measured, is actually this form. So sometimes in the past, I got many times questions that the results measured by one instrument, by DTA, for example, and compared to some other manufacturer are completely different. But the completely different was only because of this. The other instruments have shown only the resistance between terminals, and we have in DTA, we have shown only the resistance of the winding. Now, on these instruments, you have both possibilities. So if you want to compare with the others, you use this one. If you want to have these results, you take this one. This is, I think, the answer to the question.
Okay, I think we are close to the end of this webinar. I believe it was interesting for you as well. For us, was very nice to have such a lot of questions at the end. So thank you, everyone. Thank you, Pavel, and get back to Tamara.
Thank you very much. That was really detailed. From the quantity of your questions, we're very happy because this is a proof to us that you're interested in this product. We will support you in any way we can, so you can continue to ask questions or send us some suggestions, idea to your local area sales manager, and we will then distribute it internally. Or to academy@metrel.si. We will make sure your question is answered. Thank you for joining us. We hope you enjoyed our webinar, the same as we enjoyed it preparing it. Please follow our newsletters, and we will soon be sharing some more interesting topics with you. Thank you and take care. Bye-bye.